Ladies and gentlemen, it doesn't really need any further introduction. So let's just let him in. Let him in. Marco Pivetta.
Yeah. All right. He who's been dealing with our bullshit all day. Come on, some noise. All right, I'm gonna be fast. Sorry, I made way too many slides, my mistake, but I like talking a lot. I'm like Chris, except I never stop. I'm Marco. This was my mouse cursor in 1998. It became my avatar. If you see this on the internet, and it's probably on GitHub, it means I'm either reviewing your code or lamenting something on GitHub or on Twitter. I used to work a lot on the Zen Framework project. We changed name. If you didn't hear the news, we're now Laminas and Mezio. And I've been maintaining for a lot of time Doctrine ORM. I'm no longer an active maintainer. I gave up. It's just too complicated. Enough, please. But it means I've seen things. I work for a company called Rove. We are consultants. I hear that we pretty much run the conference here. And we sponsor it too. I don't know why. It's just like effectively making this happen. It's beautiful. It's good to be here again. Nice people, nice weather, good conference. Thank you for having us. As a disclaimer, these are personal opinions. I learned them by effectively working on projects where I had to deal with all this bullshit. There's a lot of self-deprecation humor, so don't be offended if you feel like, oh, we work that way. Why is Marco sniping at us? Yeah. So please draw your own conclusions. Don't take what I say for granted. Think with your own head. So this is how I sliced you up. It's mostly an architecture talk about how to keep things maintainable. Software architecture is a complex topic. There's so many things to consider: team type, project type, formality, the scale of the project, like is it going to be a spreadsheet or is it going to be Facebook storage to use, and the structure of the project, and how you're going to get it live. I know it's going to be Kubernetes just because you want to try it. And yeah, some of these will be constraints. Some of these will be your choices. If you take a project in your hand and take decisions, make informed decisions based on the constraints you have. Let's start with team types. Team types. You start with a solo dev, also called cowboy developer. I know it's not very in line with times. It's just how we call it. Solo dev is relatively simple. You start, get your coffee, start developing, maybe get some sleep, maybe chill out, deploy, go back to coding. It's a relatively simple flow, and it leads usually to working software, but a mess. So you have fast changes. You have sometimes Bucatini code. Bucatini code is a variant of spaghetti code, which is even worse. So for those that don't know Bucatini is like thick spaghetti with a hole in the middle. Right, so you get sauce inside, so when you spin the spaghetti, the bucatini, to actually eat them, sauce goes all over the place, right? Then comes the small team. This is relatively where everyone is sitting, probably. Small team, you start having some overhead. So the day starts, oh wow, the contrast on this is terrible. Let me try. It's better. It's a bit better. Anyway, they do a daily, they meet with the daily, and the day starts. This is still terrible. Anyway, and I broke it. Oh, there we go. And then you also have a workflow where a discussion comes in. You're no longer just working solo. You have to discuss things. You have to get them reviewed. Reviews take time. Development, fixing up adjustments takes time. So what you end up with is effectively kind of like a little tiny waterfall. It's inevitable. Yes, I use a Gantt chart, sorry. I had to, just because the tool allowed me to use it, so I had to be a bit managery. So this should also be seen as added value. The outcome is discussion. The discussion produces value. The code is the byproduct. What happens, though, is that you start having a mess of communication because people talk with each other, and they form knowledge that is not shared with the entire team, which is also why you need to sync up and have a meeting. So to have a meeting, you form a pentacle. And then in the middle of the pentacle, you do Scrum, right? And that's how you deal with it. You reduce the amount of noise by effectively having people meet up. A small team has a structured way of working, usually. I've seen messes on here too, which means that there's documentation. You have still very fast changes. You have decent quality coming out of it. Right, so far so good. And then comes a large team. I put team in quotes because a large team forms when you have explosive growth. Have you ever heard a call from a recruiter? We're forming a large team. Come and help us or save us, whatever. You know, we pay well. So the idea is that you have a lot of people put in a room and you watch them fight. Effectively, a large team has smaller teams in it. They will form naturally, so change is inevitable on that side. They are not formalized, but they exist, these small teams. These are kind of like team types. Then you have project types. I am not a project manager and just making this very simplified. Let's start with the prototype. The recipe for a prototype is that you start developing, then you break it, you go back to the developing, and you fix it, then it's still broken, then you deploy it. Once it's broken enough, you can deploy it. You can ship it, and then you cry in desperation, go back to development, it's still broken until you leave the company. That's the prototype. The prototype has the advantage that it is value, though. It has terrible quality in general. It's like something slapped together, making it work quickly. The idea is that you try it out and throw it away. But practically what happens is that every freaking prototype makes it to production and becomes production. Production projects, every one of us has to maintain them. Some guy built them 20 years ago, and it's still rocking, it's still bringing value. So sometimes it's not even that bad to have a prototype. And did I mention that it breaks often? Yeah, they're always broken, all the time. Then there's the project type where we need another year. These projects are never ready. So the idea is that you start by doing a big design up front, you sit at the drawing board and you design, then you wait some time because you need to assemble a team or take more decisions or sit over it for another week. Then you go back to the whiteboard because nobody remembers the decisions that were taken because it's unstructured still. Then you go to development, and the developer comes back and says, no, this doesn't work, let's go back to the drawing board. And you repeat this cycle until you're out of money and you go bankrupt. So that's the typical waterfall project. So the idea is that our code is not yet perfect. These are government projects, very formal projects, with lots of specification up front, terrible to work with. Good money, though. Huge business risk. Effectively, you are going to probably lose all your money if you start working on those and they don't work. Remember, software is 50-50. 50-50 that your project will work and bring money, and 50-50 that your company will go bankrupt. That's how it is. And yeah, it's a waterfall. After that comes an even more formal project, but of a different kind. This is where you have legacy. You have a project that produces money, and it's nobody ever got fired for buying IBM. These are large corporations. They have their own way of working. Nobody touched that. It's sacred. Produces money, don't touch it. Except for people like me, I actually did the opposite. I recommended against IBM on a project and told them that they could deploy it on a Raspberry Pi, and they fired me. I mean, yeah, you know, save 40,000 euros a year, but fire the consultant. Fair enough. Anyway, these projects are driven by meetings. Decisions are taken in meetings, in boards, of consultants, of more boards, and so on, and committees and whatever. So your change needs to go through a massive chain of approval, and it's problematic. And if something works, you don't touch it. If there's a legacy system that produces money or does whatever it's supposed to do, but burns a lot of money, but it's interesting to somebody to pump up the budget somewhere, you don't touch it. What is interesting about this kind of project is that productivity exists, but it forms in back channels. So people, specifically some proactive actors, start doing actual work, avoiding all the rules and getting to work. And what happens is that you now have this shadow company behind that is doing things, and they become a huge buzz factor. So this becomes the have you asked Joe kind of problem, where you always ask that one person who knows everything because that one person cares about the job rather than just the pay. There's open source. In open source, stability comes before quality and comes before delivery. If it's not ready, nobody cares, right? And there's generally no deadlines. Problem with open source is that it starts really, really, really fast. You get a prototype out there, works, everyone loves it, people start using it. And now you're slow. The more people you have on your project, the slower it gets. A good example of this is WordPress. WordPress is a project that brings tremendous value, but changing anything will break somebody's use case, somebody's space heater, you know? So yeah, you get slower and slower. And then there's the agency projects. Agency projects are a bit weird. If you're an agency, happens. That's a valid business area. You have a customer, which is more important than the project and the quality and keeping the project alive. It's more about, is the customer going to be happy next week? And the difference, the problematic loop is that the customer is not the user of your project. So the loop is with some kind of stakeholder. This happens in startups. Startups are agencies with a stakeholder that takes decisions. That's what a startup is. Then comes scale. Usually you have the only administrators use the system. This is when 2 or 3 people use the internal system that you're building. The system is super secure, and the reason why it's super secure is that nobody knows it exists. But nobody actually cares. It's probably in an intranet or so on. And they're probably better off using Excel or phpMyAdmin than actually building software around it, which is perfectly valid, but these systems exist. They usually try to sell themselves as super complicated, super interesting, but it's just the 2 or 3 people using them in the backend. Then there's big data. When people tell me that they have a big data project, I ask them, is it more or less big data than this? So it's a USB stick, right? And a lot of people actually say, oh yeah, we're big data. How big is your database? 1 terabyte. That's not big data. That's a lot of data, yeah, but it's not big data. And then there's actual big data. Actual big data, you probably collect lots of data. The problem here is backups. Your backups come with a truck. You literally need to order an Amazon snowmobile. I'm not sure if you've ever seen it. It's literally a truck full of hard drives. It's ridiculous. You are not here. People in this room are very likely not on this kind of project. End of story. And the problem that these projects have are on privacy and how to collect data and how to filter data. It's not about how the application works. It's more about, we got this bunch of data and now we need to clean it up before the government finds out and we're in big trouble. Right. So the architecture can influence some stuff. The architecture should avoid hype. We had microservices in 2012, and everyone was starting doing microservices. We had single-page applications in 2015, and everyone started doing single-page applications. Oh my God. Anyway, don't do hype-driven development. You are supposed to do your thinking. Changes should be factored in, so don't be attached to the software you're building. If you can throw it away, that's good value. Any software you throw away is software you don't need to maintain. It's reduced cost, right? Don't be attached to your old car. Get it scrapped if you don't use it. And it is supposed to serve the team that is working on a project, both on short term, which means it needs to give it a sprint, a speed, a velocity to get started, and it also needs to support long term. So how do we make sure that this thing is not going to crash and burn in 6 months from now or in a year from now? The keyword is that we are designing systems. System is a very, very inflated word, but it means a bunch of stuff thrown together and it does something. And the system needs to coexist with how the company works. What's interesting is that there's this guy that somewhere in the 70s, 80s, I don't know, I wasn't even born, came up with this nice law. This is Conway's law. And Conway's law says that if people talk in a certain way, they are going to design systems that work in the same way and that are structured in the same way. So, what can we influence as architects? As architects, we can probably not influence the teams. We can probably talk with whoever is responsible for organizing teams. We can change the project type. If it's a formal project, it is what it is. If it's an informal project, it is what it is. We cannot really change the scale. If the project is supposed to serve the entire population of a country, that's how it is. If the project is designed for 3 or 4 administrators, that's how it is. Those are constraints. What we can certainly influence is how we deploy a project, and what we can influence is how the project is structured from a code perspective. And there are some principles. Also, these principles come from a book written by John Gall, I don't know, John Gould? I don't know. Systemantics. It's called the Systems Bible nowadays, if you find the newer edition. And this is a book about failure. This book tells you how things break. And it analyzes that and figures out what could be done differently or what actually is the defect in the design. And the idea of this book and the concepts that are interesting of this book can be summed up in a few quotes taken from the book. So one is that a complex system cannot be made to work. So if you have a complex system and you dump it on somebody else and say, now make it work, you can't. It doesn't work. Relatively simple. It either works or it doesn't. You can't give an old crappy system to somebody and say, make it work. They're going to make some of it work, but they're not going to understand everything. A simple system sometimes works. So if you design a new system from scratch, it sometimes works. That's really, really useful to know because it means that you should start small and simple. Some complex systems actually work. Example, human body. I don't know how many billion cells there are in me. I'm not a perfect system, absolutely not, but somehow working, right? For now. And a complex system that you design from scratch never actually works. So you have complexity, you factor it into design, put everything in there, nothing is going to work if you come up with the system in one shot. Never ever going to work. What is interesting though, is that you have to start from scratch with a simple system. So the key to this is divide et impera, which means divide and conquer in Latin. It's just a way of butchering people that the Romans had. So how do you identify a subsystem? There are some things that have been very popular starting 2016 onwards. One of them is, well, Conway's law, I quoted it, that's been around for a while. But the other thing is domain-driven development, bounded context. What is a bounded context? There's talks about it. I don't want to go in detail. The idea is you make a circle around a number of concepts that a set of people inside your company understand and share beliefs about. Okay? They talk about this circle containing this stuff in the same way. That's what a bounded context is. So, yeah. When you start building a system, how do we design a new system? Kafka, Kubernetes, talk to each other, maybe? The trick is effectively talking to each other, right? Talking to each other, you can storm it. One thing I really like to do, and I've done it with many, many companies, is to sit around and do some mapping. Figure out what concepts are. There are in the system, sorry. This is an event storming session, but you can do context mapping, example mapping, mind maps, map, whatever, everything with maps. And this helps you identify those circles around everything. And now that you have a system kind of like split up in little bits, you can start with actually structuring a repository where to work. And my endorsement, and this is kind of like focal of the talk, is start with a monorepo. Don't give every team a little P corner and they do whatever they want in their corner, but start with the monorepo. And from the monorepo, you actually build multiple packages in it and maintain them in there. The advantage here is that everyone sees everything, at the beginning at least. For at least a couple years, this is perfectly fine, even if you have 20 teams working on it. It's messy perhaps, but having things under everyone's eyes means that everyone learns from everyone if they're interested. They need to be interested. This is also coming from 12-factor app as a concept. And that's also like something like 2009 concepts and principles of developing software in general. So this is good for teaching each other how to build software. If Andre works on PHP Stan and develops a component that is level 9 quality for PHP Stan, the team that is maintaining the component close by can see, oh, look, they're doing stuff this way. Maybe we can also pick those ideas. It reduces the bus effect, because now I can move people from one team to the other, and they can keep working. Whereas, check out this other project that is somewhere else, and start developing, and you're like, oh, I have no idea how to start from here. That's going to be more complicated. It reduces communication. Remember the pentacle? This is the pentacle. You now have it in a repository. That's the idea. It's kind of like an interchange hub. And you reduce the amount of time you waste in figuring out where to find stuff in general. So, the other thing that happens is that you encourage good rivalry. So teams can actually race for who is building it better. Doesn't need to be. Rivalry usually leads to toxicity at some point, so be careful about this one. So, how should you split it up? How do you cut it? One important thing is you divide by context, not by infrastructural layer. So you divide, in this case, you have an organization, you have a payment context, an invoicing context, and a shipment context. If you start dividing by controllers go here and views go there, what you end up is, I saw a nice quote yesterday, I think it was from, I don't remember who it was, sorry, I didn't factor it in the talk, but it's like taking your library and sorting books by color, right? It's not really useful. And sorry for whoever it was, I'll probably quote it later in Twitter, make sure it's visible. Then you subdivide by layer afterwards. So once you have your context inside there, you can divide things by color, if you like. So this promotes cohesion, which means putting things that have similar responsibilities together. And we are still fighting coupling, though. So we are keeping those contexts separate, but keeping things that are inside the context close together. So you can subdivide by layer, and you can decide to have an application, domain, infrastructure separation, an adapter, business logic, and I don't know, third-party components. You can use presentation, logic, and adapter, whatever you prefer. I don't really care. MVC, ADR, some other garbled words nobody really cares, but take the decision of how to build it inside the component afterwards. And then give some freedom to every package. If one team needs to work with a dedicated Docker image, let them be. They just use a Docker file in there. Another team needs to have a team directory. Another team needs to have pictures in it. Sure. And then what is important, though, is that every package should test itself. Make sure that you have testing, that quality is built in, that the team is responsible for shipping something usable, and not just experiments that effectively are going to slow down everyone on every team. So rules, same applies for coding style, PHP CS, I don't know, PHP CS fixer, if you prefer that, just use that. Some teams may use Psalm, some new teams may use PHP Stan. Not very important, as long as you have some freedom of movement. Basically, that's your directory. There's some ownership around it. I'm not going to step over your feet, but let me work my way on my side. And as a start, again, start from a simple system, start keeping things relatively simple and isolated, but it's perfectly okay to declare one big composer JSON and start from there. This also means that every package can use every other package. Yes, that is a problem, but it's still useful to start simple, have the dependencies declared in one place, and move on from there. So this will only work short term because it will explode later on. This is inevitable. If some other team starts doing things in Java, you're not going to deal with the composer JSON for Java. Okay, that's just not how it works. So now you have this one big thing. You need to set some rules on how to avoid everything talking to everything else, which is going to be a problem. So the fight is against coupling, not cohesion, coupling. Coupling is problematic. And you want to avoid specifically bidirectional coupling. So components can talk to each other, but only in one direction. If you have both directions, then it means that those are basically the same component, and now you have a problem with how to deal with them. And one interesting thing is that if you have a clear one direction graph, a directed graph, then basically you have an idea of which component may affect which other component. So you know changing this may break everything, changing this other thing may only break this single page somewhere else. So by looking at the dependency graph, you can also figure out what is needed, what is in need to be tested every time you do a change. You don't need to test everything all the time. You can have an idea of which areas are affected by your change. For this, there is a tool called DepTrack. It's built by Cosmic. I have no idea how to pronounce that. Cosmic is the previous Sensulabs Germany. The people there have done really, really good work on this tool, and I recommend you try it out. And what you do is you configure in YAML, sadly, it is what it is, but you configure a set of directories that this tool is going to look at. So you are going to say there's a payment context, it has its own directory, invoicing context, and shipment context, right? And down here, you effectively say, all right, payment can't talk to others, invoicing can talk to payment, and then the shipment can talk both to payment and invoicing. So that's quite useful to figure out how to make a directed graph. This will also generate a nice diagram for you. Very, very useful to figure out how the application is structured and which team depends on which other team. And if you do something wrong, it will also tell you that. It will also tell you where it is, kind of like PHP Stan, just dedicated to just this one problem. So you have to have one top-level dep file, and then you can have multiple dep files inside the packages, because remember, every package is responsible for their own quality. If in one package we have a rule that controllers only talk to certain systems, then you can define it there. Another thing you should do is defining internal rules. So declare classes as internal aggressively. There we go. Internal. And there's also Psalm internal. Psalm internal here, this guy here. It effectively allows you to say, this class is internal, but only to a certain namespace. Really, really useful. Sadly, we don't have it in PHP. Some terrible bank, yeah. Banks are terrible. APIs of banks are always terrible to work with. So don't make everything public. Try to keep things as private as possible. Remember that it's going to be under everyone's eyes. So design as if you were building an API. Use final aggressively. And inheritance is a bidirectional link that you form immediately. Inheritance has this problem that it's always bidirectional, even if you don't see it directly. Internal and Psalm internal will always set some boundaries around what can be used by whom, and deprecation rules can be used to start phasing out things and helping other teams moving forward. For continuous integration, my recommendation is to start by testing everything for 2, 3, 4 years or whatever. You're going to be fine. You can't write so much code or mess it up so much that you need an entire build farm in 3 or 4 years. Yeah, I know there's some people are capable of doing that, but yeah, check everything, wash everything through. You don't need to have like just some context tested. And in future, what you can do is use the dependency graph to figure out what has an effect on which other tests. One interesting thing is that if you're like literally Facebook scale, they built that. They have one giant repository with everything. I don't know if that's still actual. And if you change one thing here, it figures out that this other thing down here is also affected. And they have an automated system for that. If you have money to throw at this problem, throw it when you have the money to throw there. The agility on this project now is retained by smaller teams. As I said before, small teams are key to achieving quality and velocity. So start with built-in qualities, which means test, test, test. Quality tools, tests, and tests again. I don't care if you have the strictest types in the world. If you haven't tested it, it doesn't work. A system that doesn't run is not useful. And you keep the documentation in packages. Again, documentation. So you keep the docs close to the context. So don't take that documentation and put it somewhere in Confluence. I've seen it every damn time. The documentation is somewhere unreachable behind a VPN. I have this one project where I have to use Docker for developing, and I have to connect to the VPN to look at Confluence. But if I have Docker enabled, I can't connect to the VPN. And if I have the VPN connected, I can't start Docker. So which is going to be the winner? I'm never going to look at the docs, and I'm never going to contribute to the docs. End of story. So another thing you can do is declare your API explicitly, maybe have a namespace. We know everything is there. In there is API. Everything else is forbidden. Everything else is verboten. So won't the repository become enormous? Yes, it will grow. But on the other hand, how much do you actually download for a video game nowadays? I've seen video games where you need to plan a weekend ahead if you want to play with your friends because the newer patch came out. So you're now trying to play and you can't because it's downloading. It's only downloading. The game is actually de-downloading is the game. But so the repository will grow, but over multiple years, it will take time for getting there. And on the other end, Git is ridiculously fast. Git can shallow clone. Git can use large file system for large files. There's multiple tricks, but effectively, for the first 2, 3, 4 years, you're going to be fine. Don't make it more complicated. Will it be overwhelming? Yes, you now have a project, you open it, and there's Rust in it, and Java, and I don't know, whatever iOS developers use nowadays, and so on and so forth. Yeah, it will be a bit of a mess. What you can do is you can literally just open the subdirectory. You don't need to open the entire project. You can open the subdirectory, right? I don't know why many people think this requires a dedicated repository just for opening the IDE on that repository. You can open subdirectories. It's always worked since Aptana. Since, I don't know what we used before Aptana. Anyway, so you focus on your package, you know what you're working on, do focused work. You can still open the entire project if you need a reference, an idea of what's going on. This is also going to be a bit more helpful if your IDE is, burning RAM for loading everything in memory. Code reviews, there is a code owners file. For example, here I'm declaring that Marco and James have worked on the payment component. So it would be a good idea that before we break the payment component, we should perhaps ask them. And you can effectively assign reviews to certain teams inside your organization. So yeah, you can use that. It doesn't need to be. But effectively, this prevents spamming everyone for every change. So just to reduce the amount of notifications. The dependency graph is a double-edged sword. You now have the clarity that who is using your components inside their components. But on the other end, you need to somehow phase out stuff. So people are using your API. You now need to declare your API dead because you want to move on. So what you can do is literally inside your component, deprecate, make a new namespace, move on. Phase out old revisions by literally throwing them out, rewrite. This is kind of like the idea behind microservices, right? The idea of microservices should be small enough that you throw it away and start from scratch. That's the idea. So this way, you retain your agility, your ability to iterate quickly, to do experiments, to move on. In the future, when this grows and grows and grows, some teams will say, yeah, we need to build this in Rust because we have this other vision of the world. It's going to be like that. It's unavoidable. You also can't hire just PHP developers. There's also other organizational problems. You can't just hire for one programming language. You will have to separate. Also for skills. PHP is not the right tool for everything. So you can start declaring per package dependencies. So here you have, for example, a package declaring composer dependencies, right? These two are declaring composer dependencies, and this down here is working with Rust. So what you can instead do is declare per package dependencies. Sorry, that's overlay there. And one interesting thing is that Composer is supporting this by declaring everything in place. You don't need to publish to some statis, to private packages. You don't need all that complexity. You literally point it at the local directory. Works. Don't need to make it more complicated than that. So check your dependency graph for gaps. Once you start having every team declare their own dependencies, try to be a bit more careful that dependencies don't accidentally change. So make sure you check them. There's this tool called MaggleNet. Matthias Glaub is the name of the guy. A Composer require checker. It's a package that I hijacked and I started maintaining. And yeah, I'm shadow maintaining that. Shipping. Please avoid git flow or any variation of that bullshit. It's so complicated. You're just introducing complexity all over the place. If you start doing git flow with multiple teams, nothing is ever going to happen ever, right? Because you have to wait for 7 departments to check your changes before they go live. No, this is something that you need to somehow shoehorn through. Organizations are going to fight you, but use something simple like GitHub Flow, and you test maybe on simulated merges. You don't necessarily need to rebase all the time, but simulate on a merge. Make sure that your changes are compatible with the latest changes from this morning, for example. And then if it is checked, it passes all the tests, and it is reviewed, ship it. Don't wait for some other team to manage deployments. Deployment is for everyone. So for deployment, your local development environment should allow you to reproduce kind of production systems. This is again from 12-factor app. You start developing with one Docker container. You don't need to develop 20, 40, 60. Start with one. It's one web server, right? It's going to be one company dealing with it. And then from there, go on and separate if you need to, but start simple. And deploy at every change. I don't care how you do it, but make sure the deployment is happening every time, that everyone knows the deployment. So if I fail or if I succeed, I've done it together with my team, and not that there's blame happening 1 month later because we pushed the deployment with 1 million changes and nobody knows what changed and what broke production. So 12-factor effectively says you can have one repository and multiple deployable targets. The idea is that you can still decide in future to have one web server here and another one here and another one over there, and still deploy from one code base. You don't need to split that. So multiple targets are possible, and it's the way you effectively scale out your system. But important is the deployment configuration stays inside the repository. This is also something I've seen hundreds of times. There is a DevOps team, quotes, because obviously we did not understand DevOps. They have their own repository where they do their own little Kubernetes thing, or whatever it is, and nobody understands it. And then when the deployment fails, everyone goes to that team. And nobody actually knows how it is developed and how it's supposed to work, because it's not under everyone's eyes. Little diversion. Okay, so now we have multiple processes, one repository. Should we go microservices at this point? We can do it, have multiple microservices inside one repository in theory. A bit of a rant here. Microservices, it says so in the name, it's microservices. Basically means never services. But yeah, sorry, it's an Italian pun, but microservices have a common problem, at least RPC microservices, which is what I see everyone do. And it's that you have a system where you have a shopping cart, and a shopping cart needs an inventory and a checkout system to talk to get information or to perform operations. And then those systems, like the checkout system, talks to payments and shipment, and those are also services. And then the payment system talks to invoicing. What's the problem here? Well, the problem here is that every one of these has an availability that can be kind of like estimated. And when you multiply it all together, 99.9, multiplied by itself 6 times, is effectively 94.1%. This means that 1 in 20 HTTP requests will start to fail. And this will only get worse and worse as you add more services. And there's nothing you can do against it. It could be that somebody's deploying, it could be that something went wrong, it could be that somebody tripped on a network cable, like this cable here. It's just freaking me out a bit. But yeah, this is really bad. So you need to be this tall to do microservices, okay? That's how it is. I don't think anyone in this room is this tall. So you also have problems with BC compliance, where the compliance is not just internal to the code, but also at API level. So going back to the definitions of which Rob was talking about earlier today, that needs to be compliant long term. You have to now coordinate deployments. Networks always fail. And effectively, the network boundary, once introduced, is really hard to remove. So you build something in Rust that talks to something in Go, right? You can probably decide to merge it one day, but one of the two will need to be rewritten. You're not going to get them running in the same memory space. And you want to keep things in memory. Every year, we get something like 7-8% CPU speed up for single process in-memory operations happening in the CPU. Now, PHP is terrible at that, But remember that going to the CPU or going to the network card is a factor of 100, if not 1,000, in speed difference. So microservices are perfect if you have multiple teams that hate each other to the point where you have a toxicity problem in the company and they would like to just fight with each other. This is a political problem. So it is a workaround for corporate politics. You have corporate politics problems. It's a workaround to effectively split teams, get them productive, and avoid having a homicide happening. And effectively, technical tools don't solve political problems. You're just working around them. So you just took the problem, made it explicit, following Conway's law, you split those teams, they don't work well together, keep them apart. And it's also good for mortgage-driven development. So if you are one of those architects that promotes AWS services and you're playing buzzword bingo and you want to put every microservice and every AWS service on a diagram, perfect for you. You're going to also have it work for the next foreseeable future. On a monolithic system, this is not necessarily better. So a monolithic system has still this problem. What you get is you get the failures because subsystems still crash, still have problems. So if you go RPC style, you still have those problems. But what's good is that it's in memory, so you get a decent stack trace, and you don't need to jump over logs for 5 services before you find the root cause of a problem. So what's a better approach to this? It's reacting to events. If you have an event system, an event-based system, PSR14, event sourcing, whatever, and you have a cart, and in this cart you add some items, and then you get to the event that the cart got bought, then you can have another subsystem, like the payment system. It could react to the fact that we are purchasing the cart, and it can fire its own events, and then another subsystem can register to that, and the billing system can start creating an invoice starting from the requested payment, and so on. This is reactive microservice patterns. It works for microservices. It works also for in-memory processes. But again, for microservices, you need to be this tall. Don't go there. Start with in-memory. This would be a PSR14 dispatch system or a message bus. It could be synchronous. It could be asynchronous. It's your decision where to go with it. But the good thing is that now you can scale it out. You have more operations to do. You just add workers. Every worker will pretty much be just a worker that deals with these events and does something with that. And in future, you may even go to event sourcing. I like talking about event sourcing, but again, no hype-driven development. Take your decisions. Make sure that the scope is the right one for this technology. So on splitting repositories, avoid. One sad thing about code is that code that is perfect is never looked at. Code that never fails, never brings a problem, is always perfect, always works, and does what it does, nobody looks at it. Nobody will learn from it because it's usually somewhere in a corner and nobody needs to check. It's the ugliest, worst, unstable code that we need to be aware of. That code is what is going to fail and we constantly have to repair. So if you don't put it under everyone's nose, nobody's going to see it and learn from it. Another thing is that once you start splitting repositories, this problem with shadow organizations where people work in a corner, isolated from everyone else, is just increased. So you get these little pockets of people that are doing useful work, but those people are effectively in a corner. They do their own thing, and nobody really talks to them, and you increase the bus factor. So avoid splitting until you have a huge political problem of some sort, and then you need to split. It will potentially happen, but avoid it until possible. So how far did we get? My endorsement for splitting an application is to keep it in a monorepo, have the code structured by context, not by technical implementation detail, have all teams co-own it, make sure that teams work on the same code base, have a clear dependency graph so that you don't basically mix everything together. If you do that, you're going to be in trouble. And retain your agility by effectively being able to take one of the contexts and rewrite it, as long as the public API is still viable for other components. Will this work? Well, will it blend? That is the question. So for the solo dev, this is probably a bad idea. You probably just want to go with prototypes. If you're a solo company, you don't need to this massive structuring of things. You don't know if there's growth yet. You don't know if there will be growth. Perhaps hold it off. It's just going to be a cost to organize stuff this way. For a small team, yes, absolutely endorse it. Small team will pick this up, and people inside the team will take their area of preference and take ownership over time. For a large team, well, a large team is always problematic, but what can happen is that people start taking ownership of areas. And if certain people take ownership of those areas, you may have some structuring that is now possible. Remember that we don't drive the organization, it's the organization that drives the code base, but it may help. So for prototype projects, absolutely not. Get your index.php, don't install a framework, just get the prototype done. Don't build anything more than that. For the I need another year, the good thing is that instead of having one waterfall project, you now have a smaller context. So you now have a way to split work and make it a bit more manageable. It's still going to be mini waterfall, but yeah, still better than what it was before. For the large IBM systems, where nobody got ever fired for hiring IBM, you may effectively gain something by making contexts that talk to legacy systems inside the company. So these companies usually have running services. You just have to talk to them, and you can't touch them. But what you can certainly do is start documenting how each of those works whenever you need to talk to it. So you make a context and talk to that service, talk to that other service. For open source, I don't know. Symfony has success with it. Other frameworks don't, but effectively, it puts a bit more burden on random contributors that just want to work on a small area and now need to figure out how to contribute. And now they fix a problem here and bring problems all over the place in the library. Yeah, I'm a bit undecided on it. I prefer smaller packages. And for agencies, this is fantastic because you can make per customer a context. So you make customer 1, context 1, customer 2, context 2, customer 2, context 3. Right? You don't need to necessarily group by just customer. And it works as long as there's no customer-specific secrets, like we do this shady stuff that nobody should know about, and only certain people in the company should know. So, will work for certainly small systems, will work for the big data systems like everyone else. Very, very actual big data, it may not necessarily work, because now the problem is not really about how to split the code, but rather how to split the data and keep it separate. So, single code base may work, but some separation may be necessary at some point for legal reasons. All right, that was it. That's my view of how to split applications and keep them manageable long term. So if you have any questions.
All right. Any questions? One over there. Also one from the online audience.
So thanks, great talk. And I had to be that guy, but not a question, a comment. DepTrack in the latest version actually supports PHP configuration. It's just not documented yet. And currently there's a few bugs, so the next version will have it documented.
Nice.
And I'm also working on, because the dep file can be really large, to actually define your layers and rule sets as code. So if you have a structure like yours, you can basically look at your directory structure and infer the layers, and then also infer the rules. So you don't have to have these big config files. It's still early work in progress. If you have any questions regarding DepTrack, feel free to come to me. But yeah, just want to say you don't have to use YAML now.
Okay, perfect, perfect. I'm gonna get rid of it, all of it, at least. Xabu, right? Right. Xabu. Fluman. No, it's nearby. Sorry. There we go. But we got the Symfony guys. All right. Yeah, I mean, that's good news, at least. I can get rid of some YAML. It's always good. Was another one, I think. No?
I can read one from the online audience. So Andy asks, deploying at every change, can you elaborate on that? Is every change a direct release to production, or is it first deployed to testing environments and then wait for manual acceptance?
So my idea is that you should always go straight to production. If you have a system that checks for your code to be correct, you should just go live. By doing it more often, you will learn about painful stuff like, oh, SQL migrations actually need to be backwards compatible. Oh, we didn't know that. Or stuff like that. So it's best to do it often, do more of it. If it's painful, repeat it more often and learn from it. So that's really, really important. Do it often, do it all the time. You should not have a staging environment where you test things manually, where there's a team of manual testers. That's like more investigation work that should happen. I did another work about extremely qualitative something applications in PHP, but the idea is that you always deploy, and then your QAs will effectively try ordering 1 million products from your e-commerce that is live and try to break it. Don't do it the other way around. Otherwise, what you end up with is a staging system where everything gets stuck because our QA guy is sick at home and can't work, and now you have 2 weeks of changes going to staging, and they completely accumulate, and then your problems go to production, and now you have 2 weeks of work suddenly landing in production, and you have a massive pile of work. My suggestion is it merged, it got production. That's it. Relatively simple. Yes, it's simplistic. It makes it a bit scary for people to work with it, but you should also like have a direct feedback. Oh, payments are no longer working. We're losing payments. Okay, let's do a revert. Let's look at it again. And you push, and it's live again. No need to make it more complicated than that. A whoops should be immediate. It shouldn't be waiting for 2 weeks to happen, and then half the company is scrambling for understanding where is the whoops? Where did it happen? That's just too big. Don't do that.
Another question there, in the back.
You mentioned deprecating certain parts and then rewriting it, but how do you then retain business logic with rewrites?
Retain business logic. Right, you have a test suite, and the test suite in theory contains a set of verifications of business rules. So yeah, you call this endpoint 3 times, and then this other endpoint 1 time, and then this should happen. That stuff should pretty much always run, and you just replaced how it works behind the scenes. You replace the code, but the endpoint still works. So you have multiple levels of testing. You have unit tests where you test single classes. They get constantly scrapped, thrown away. Whenever you rewrite, you just literally write the new test for the new class. But when you plug it into the system, and the system as a whole behaves in a different way, you know you broke something. And usually the higher level integration tests tell you if something changed behavior in a radical way. Okay?
Last question here. I'm going to give you.
Hi. What do you think about moving from projects that start as solo or not in a domain-driven structure and then move on to become bigger and therefore may need a domain-driven approach? Is that doable? What are the hardships or that?
So working currently on 3 large projects where this happens. They have written code that brought value. It works. Kanban box is there. Hands up. Kanban box, come on. They're also sponsoring. I work for them. They have to endure me every week. My rants about how they write code. I hope it helps though. But yeah, you have this code base. It was written. It works. It brings value. It's useful for companies, but it's not perfect, or you may need to rewrite parts. What you do is you either start moving stuff and replacing, kind of like what I was saying. You have the tests. You are moving it into another area, and it still kind of works the same way, or you deploy often and you see that it still works the same way. Not everyone has the capacity to add tests on top of legacy code because it's very expensive and they're going to be end-to-end tests only. And the other thing you can do is you can use something like the strangler pattern for backend applications. The idea is that you have 2 backends. One is old, one is new, and a front controller or a load balancer or something like that, that for specific calls, for specific endpoints or specific pages, goes either to the old one and the new one. So what you do is you write code in the new structure, and then you make sure that it's tested, that it's doing what you want, and then you switch over, and you see if it works. And once you switched over, you can delete the old code in the legacy system. And that's one possible way to deal with it. There's multiple projects in multiple ways. They deal with these issues, but you can migrate and make it a bit more context-based. And all this experience of tens of years of development, you are not going to lose it. You're just going to move it, structure it again, make new ideas that you formed over experience working with your customers, and put them in a more manageable thing that effectively new developers can take on. Because until it's a mess, it's also going to be problematic for new developers to fix that mess. All right?
All right, time is up. So give it a big round of applause to Martin.
Thank you.